So in the past 4 sections, we've talked about 4 different ways to tell if triangles are congruent. We talked about side, 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 angle, angle, and angle, angle, side. Now we're going to talk about 4 shortcut ways to prove that a pair of right triangles are congruent. And we have to remember these are only for our right triangles. You are allowed to use these shortcuts in your theorems because the triangles automatically have a pair of congruent 90-degree angles. So if we review the parts of our right triangle, we have a leg, 2 legs that make up the right angle, and opposite that 90-degree angle, we have our hypotenuse. Okay, so with our right triangles, our 4 ways to prove they're congruent. Our first is leg, leg. Leg, leg means our 2 legs of our triangles are both congruent. We have 1 leg matching on the side, and then our 2 legs matching on the bottom. Our leg, leg is similar to our side, angle, side. It really is our side, angle, side because we have 2 sides and our angle 90 degrees in between. We can either use side, angle, side or leg, leg in this 90-degree triangle. Our second one is the hypotenuse angle. This hypotenuse angle theorem says that the angle of our triangle here, so we have these angles up top and our 90 degrees in the corner, so it's a right triangle, and our hypotenuse are the same. So our hypotenuse angle is very similar to angle, angle, side because we have 2 pairs of angles, our 90 degrees, our angle in the corner, and our side, which is outside, is not in between those 2 angles. This HA, hypotenuse angle, is the same thing as angle, angle, side, but in a right triangle, we can automatically just say HA. Our next one is our hypotenuse leg theorem. And this one says that we have 2 pairs of sides, but one is the leg of our triangle and our other side is the hypotenuse. If our hypotenuse matches up and one leg of our triangle matches up, then it is a pair of congruent triangles. This hypotenuse leg theorem does not have one of our 4 side, 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 angle, side, angle, or angle, angle, side components. Hypotenuse leg is the one of the 4 special ways of a triangle that does not match up with one of these other 4, and this can only be used in right triangles. Okay, our next one, our leg angle. This means that we have a congruent angle other than our 90 degree that matches up, and we have a leg that matches up, is congruent to each other. So here, if you look at our 4 options, this one could also be our angle, side, angle, because our 90 degrees says right away that they are congruent. So either one, you can use leg angle or angle, side, angle in this case to prove that they are congruent. So now let's look at some examples. Which postulate or theorem could you use to show that each pair of triangles are congruent? So if we look at our first one, you need to draw in our given information, which is there's a line down the middle, and these two sides are congruent. So if this line is also perpendicular, so it has 90 degrees in both corners, we want to know which way we can show that they're the same. So we've got that line down the middle. That is our reflexive property. That line is the same as itself, so that is another pair of angles or sides that match up. So if I look at the regular way to prove these are congruent, I have two pairs of matching sides, and my 90-degree angle is matching. That angle is in between both sides, so that would be my side angle side. If I'm using a special right triangle theorem, I could use leg, because I have both of my legs in those right triangles are congruent. My hypotenuse is on the outside, and I'm not given those are congruent, so that is why I'm using leg. For B, the given information is that this side is congruent to this side, and this side is congruent to this side. Now our regular information in these two triangles is that I have two pairs of congruent sides, and my angle is outside of those two sides. It's not where those two sides come together. So if I was looking at my regular theorems, I would not be able to prove these are congruent. There is no option that says side angle. So that means that if I was just using my original four theorems, I would not be able to prove these triangles are congruent. But since I know that it's a right triangle, I can use my hypotenuse leg theorem, which means I know the hypotenuses are congruent and one leg matches up, since it's a right triangle, to prove it's congruent. Okay, for C, my given information here is that my two angles there are congruent, and I have right triangles here. So I know my side is congruent because it's the same line for both triangles. If I was looking at the regular options, I would see that I have two angles, two pairs of matching angles that match up, and my side is outside of those two angles. So it would be angle, side. Now if I'm using my right triangle theorems, I have an angle that matches up in both right triangles other than my 90, and I know my hypotenuse is the same. So that would be my hypotenuse angle theorem for a right triangle. Okay, our last example down here is asking which additional congruence would you need to know in order to show they're congruent by the indicated method. So this one says I want to use the leg theorem, and I know that angle A is congruent to angle D. So I'm going to label my points A, B, C, D, E, F. Well, if I need to know both legs are congruent, I would need to know that AB was congruent to ED, and AC is congruent to DF. That would show me that my two legs on that side are congruent, and my two legs on the base of my triangle are congruent. That is my information I need to know. For number 2, if I want to use side angle side, and I know I'm given that these two sides here are congruent, I'm going to label this as A, B, C, and D. Okay, so I know that AB is congruent to DC. I want to use side angle side, I already know that AC here is congruent to itself. So the last piece of information I need would be that BC is congruent to AD. If I want to use side angle side instead, I still know that AB is congruent to DC. But now I would need to know an angle in between my two sides, which here it would be angle C would need to be congruent to angle A.